So thanks to everyone for coming. We're really excited for this event. It's really fun to see all the different perspectives come together, and I think we'll especially see that starting in the afternoon. So the motivation for this particular paper is that quadratic voting, the baseline analysis in my paper with Steve, relies on a lot of extremely simplistic, you might even say like strange assumptions about behavior. These happen to be extremely common assumptions that economists make, but that doesn't make them any less simplistic, extreme, or strange. The motivation here is to actually try to think about whether those are inherent to what makes quadratic voting work, or whether those are simplifying assumptions that can be relaxed and you'll still get a quite similar sort of logic. So that's one motivation. The second motivation is that if you believe in all these strange simplistic assumptions that we make, then there's actually other mechanisms that you could apply that we've known about for a long time that do even better than quadratic voting does. And so, in some sense, it's not only that we're interested in whether quadratic voting is more robust, but whether it's even well motivated in some sense. Because without these concerns about robustness, there's lots of other things that would do quite well. Now, the basic idea behind the paper is that what makes quadratic voting work is not all the detailed, subtle assumptions that we make. It's really the following equilibrium behavior. So in order to get efficiency under quadratic voting, we basically need something like the following to hold roughly in the population. People have to vote in proportion to their values, and that constant proportionality doesn't need to be the same for everybody, but it has to be independent of the values that people have. That's what makes for efficiency. And that condition really is only quite tangentially related. And in fact, the fact that it took us 40 pages with Steve to prove that this even happens under all these hyper-rational and very specific assumptions, it's only very tangentially related to the assumption of perfect rationality or anything like this. It has something much more generally to do with the notion that, if you make people have some cost, the people who care more are going to do more of it on average. And I think that's a pretty reasonable assumption. And basically what this paper is about is showing that if we change lots of different assumptions, something like that will continue to be the case. Okay, so let me go through three, I think, particularly problematic assumptions that Steve and I made in the baseline analysis. The first one is we assumed perfectly non-cooperative behavior. That is, that individuals don't form any coalitions that might collude with each other. The second is that people's values were drawn independently and identically from a known probability distribution. And the third is what you could call that everybody is econs, or people are perfectly rational and perfectly instrumental in their motivations for participating in the system. All of these assumptions are pretty problematic, especially if taken to an extreme. So, there's almost certainly going to be at least some amount of collusion in the system. Hopefully it won't cause be too widespread or so forth. But you wouldn't want to assume that everyone is absolutely atomistic without any communication with each other. Under completely independently drawn values, there's no uncertainty about the outcome that's going to occur in a large population. That's not characteristic of any election that I think any of us has ever seen. So that seems like an extreme assumption. And finally, we sort of know that we couldn't explain most behavior in existing elections by an assumption that everyone is perfectly instrumental and rational. So this assumption is pretty clearly falsified by the way that politics works in the world at present. So On the other hand, there are a variety of mechanisms which, under these extremely simplistic assumptions that I said, are going to perform significantly better than quadratic voting. So the Vickery Clark Groves mechanism will get you full efficiency even in finite populations. The expected externality mechanism will get you full efficiency in finite populations and budget balance. And in large populations, there's an even simpler thing you can do, which is that if it's known to everybody what the mean of the distribution of values is, we could just implement whatever, assuming that's not zero, assuming it's positive or negative, we could just do whatever the mean of the population wants to have done. And in large populations, that's basically efficient. So why are we messing around with a mechanism to begin with, right? There's a final mechanism which, under some specific assumptions, if you just have people have costs of voting, there's an argument by Ledgerd that, and Roger has a version of this under different assumptions, but that shows that in a large population, an infinitesimally small fraction of the population will vote, and that will basically implement quadratic voting, because conditional on every utility, like the number of people that will vote will be the same as the number of votes that someone with that utility would have voted under quadratic voting, and so you get efficiency. And all of these mechanisms either perform better or are simpler in some way than quadratic voting does. So why are we even considering quadratic voting in the first place? Now, what I'm going to argue is that a violation of one of these assumptions will completely destroy the efficiency properties of each one of these mechanisms. And I'll also argue that it leaves quadratic voting pretty much intact. And this is an important part of the motivation for quadratic voting. So in particular, the Vickery Clark Groves mechanism has the following semantics. Basically, everyone says, how much am I willing to pay for Gore to be elected versus for Bush to be elected? And if the amount that I say ends up changing the decision, I have to pay how much everybody else wanted it to go in the opposite direction. So for example, if everyone in aggregate wanted $1 million for Bush and I say $500,000 for Gore, well, Gore still gets elected. But if I say $1,001 for Gore, then I pay $1 million to the rest of society, and I get Gore elected. Now, the problem with that mechanism is that if any two people were to say, we both value Gore at $10 billion, Gore is clearly going to get elected, but neither of them was definitive in making it go in that direction, and so they pay nothing. And in fact, this happens in lots of experiments with this process, is that you get two people who realize that they can both not be pivotal and get whatever they want, and then it breaks the whole system. So that's a case where, again, there's no way that there's going to be no collusion in a society. We're going to have to worry with it, but even two people colluding can completely destroy this mechanism. So that's maybe not a very good property. The expected externality mechanism says that we have to charge everyone a price which is equal to the expectation under the known to everybody probability distribution of the VCG payments that they would make. Now, if you don't know what that distribution is, or if it's not known for certain, this mechanism is not even defined. And neither is this mechanism even defined in that case. So those mechanisms don't even have any meaning in a world where we have even a tiny bit of aggregate uncertainty. And finally, the costly one-person, one-vote mechanism is clearly not going to work in a world where people have any other motivation for voting, because it relies on an infinitesimally small number of people voting, which is only going to happen if the only motivations for voting are purely instrumental. OK, so now let me try to go through each of these issues and think about them in the context of quadratic voting. And here's the method that I'm going to use to do that. So if anyone's looked at my paper with Steve, or even heard Nick and Miles referring to how daunting it is, they know that there's like 40 pages of proofs to establish things in the baseline case. And I'm just not going to do that for every additional analysis that I do. So what the core insight of that paper is that, should not be that surprising to people, is that roughly either the central limit theorem applies, or we can have like a law of large numbers, and then there's large deviations. And every statistician knows this in like 99.9% of statistical problems. But to actually formally prove it takes 40 pages in this particular context. So rather than going through and reproving it at every context, I'm just going to assume that that widely known set of statistical approximations holds here, and I'm going to calculate rates and so forth based on the idea that one of those approximations holds. OK. So let me go through the three issues. So first, collusion and fraud. So what do I mean by collusion and fraud? So collusion is the idea that we get together as a group and maybe we vote more than we would unilaterally in order to take advantage of the fact that I haven't run fully up someone else's quadratic function. By fraud, I mean doing that just as one individual. So pretending like I'm multiple people, manufacturing false identities, and using those to get around the fact that it's increasingly costly to buy votes. What I'm going to try to ask is, how large scale does a conspiracy like that have to be before it causes real problems for social efficiency? And I'm going to consider that under a wide range of modeling assumptions. So these models are going to be sort of like the combinatorial intersection of the following various cases. So on the one hand, we might have worst case colluders. So that is, I choose the colluding subset of the population that's most extreme and therefore would create the most inefficiency as a result of their engaging in collusion. Versus random case collusion, which is I just take a random subset of the population and then they get a collude. Versus fraud, which is where I'm just manufacturing multiple copies of myself. The second issue is whether collusion is perfect and undetected, or whether people within the collusive agreement might have an incentive, might consider defecting from that agreement, need to be monitored by the group, or where collusion is perfect internally, but it may be suspected by other members of the society that collusion could take place. That doesn't mean they detect a particular collusion while it's taking place. They just imagine in their minds that there's at least a small probability of collusion occurring. And then the final thing is whether we're in the mean zero case or the case when the mean is not equal to 0. And for those who've read the paper with Steve, these two regimes are very different. So in the mean not equal to 0, the key threat to efficiency is that there's a single or maybe small group of extremists who buy a lot of votes and overrule the will of the rest of the population. Whereas in the mean zero case, the threat to efficiency primarily arises from actually people who are extreme buying too few votes because they basically have market power over that decision. So these are very different regimes. Now, I can't go through the analysis of all these cases, but I'll just sort of summarize what we find in terms of cases which are good in the sense that a collusive group is going to have to be a very large fraction of the population in order for problems to really arise, and bad cases where a relatively small share of the population can cause harm. Even in these cases, the number of people will still have to be growing in population size, but it doesn't grow very fast, and therefore I think it would be a feasible manipulation. So the good cases are any times the collusive group is drawn randomly from the whole population, things are basically fine. Even if they're drawn in the worst case, extremists, or if it's fraud, as long as the rest of the population knows that there's a chance that collusion might occur, it's not a big problem. And the reason is those extremists are going to, by the fact that they're engaging in this conspiracy, dramatically raise the chance that an election is tied. If anyone else even thinks there's a chance of that occurring, that leads everyone else to buy votes. And that basically defeats the collusive conspiracy because there are so many more people that are not part of the collusive conspiracy than are part of it, that those people, because they're not really running up the quadratic part, they're running up the linear part of the cost, are going to swamp the people who are part of the collusive conspiracy. And the third case is when in the mean zero case, not the extremist regime, in the mean zero case, if the collusive group has to worry about internal defections, that will ruin the possibility of collusion to be really harmful. And again, that's pretty intuitive. In the mean zero case, things are very much like a market economy. So you can really think about this as just being the fact that if you form a collusive conspiracy and you need to worry about the fact that people might have an incentive to unilaterally defect from that conspiracy, it's not going to be possible to do that unless you control a large fraction of the total market. On the other hand, when you have non-mean zero and the population does not suspect that there could be collusion, this can create major problems. Because then everybody else thinks there's an incredibly tiny chance of the election being tied. And so they buy so few votes that even a very tiny collusive group could break that. And on the other hand, in the mean zero case, if there's perfect internal agreement within the group and they can perfectly monitor each other, then even a relatively small group might be able to cause problems. Because when the mean is equal to zero, things are very sensitive. People aren't buying that many votes. So a relatively small group, if they have no incentives if they don't engage in any unilateral deviations, might cause problems. OK. Second issue I'm going to turn to is motivation and rationality. OK, so an important part of the motivation here is not just what I said that, we couldn't explain existing election outcomes if people were perfectly rational instrumental. It's also that in the experiments that we run on quadratic voting, both in the laboratory and in the field, there's just no way people are playing Nash equilibrium. You can completely reject that without any ambiguity. And the reason is they're just buying way too many votes to be consistent with Nash equilibrium. And this is even in laboratory settings that are incredibly stylized with a relatively small population, so the chance of being pivotal is not that small. Even there, they're buying way too many votes. And the interesting thing is, despite the fact that they're buying way too many votes, and in fact, Jingjing, I think, is Jingjing here yet? Yeah, there she is. Jingjing will report on this tomorrow. Nonetheless, people buy votes quite closely in proportion to their values. Not perfectly, there's noise and so forth, but it's quite proportional to their values, despite the fact that it's not a Nash equilibrium amount. So there are 3 models that one might use to explain this. There are actually 1,000 models one might use to explain these sorts of things, but 3 that are particularly popular I decided to consider. So one is that people just have a desire to express their preferences. They get a utility from every vote they get because they just want to express how they feel about the issue. And I'm going to assume that that is proportional to their value. So the more they care about the issue, the more they get a value from expressing each other, from themselves. But there might be some noise in it. And we allow that noise to be arbitrarily broad in terms of the relative proportionality. But it's orthogonal to their value. The second is that there's an expressive motive, but it dies off with population size. So this is motivated by something that Roger once told me, which is that, if I am part of a voting public, if I change the percentages in favor of Hillary Clinton, that might give her more of a mandate to implement the policies that I support of hers. And so, I don't have much of an impact if I'm a small part of the population, but on the other hand, it's not just about getting her elected, it's about the margin of her victory. And then the final thing is that people might misestimate the chance of there being pivotal. Actually, Jingjing and Jakob say that this is what they think is going on in their experiment, though it's hard to know. It's just a hypothesis. And I assume that this is particularly the case when people are a small part of the population. But again, there may be noise in this, but it's uncorrelated with values, except by the fact that it may be larger when people have smaller values or when it matters less, their decision. So if they're going to vote very little, they may pay less attention to making sure they have the right estimate of their pivotality. OK. So in the mean zero case, non-mean zero case, these forms of irrationality actually help. So you actually get faster convergence rates towards efficiency as the population grows large from these factors. And the reason is very simple. The key problem was that there were these extremists who were going against the will of the public. That happened because everybody else was not voting very much. And that gave the opening for the extremists. But if you have these other motivations for voting that cause people to vote more, that solves the extremist problem. So basically, you get much, much faster, actually exponential convergence towards efficiency with these behavioral motivations compared to the perfectly rational case. In the mean zero case, on the other hand, there is limiting inefficiency, and it comes out of the noise. And you can, again, think about this in relationship to a market economy. In a market economy, we know that if people are behavioral, if they make mistakes, then things can be inefficient. But the question is it worse than one person, one vote? And again, I'd make the analogy to the market economy. So in the market economy, we could say everyone is so behavioral, let's just ration all goods to people, allow for no trade, because any trade is going to lead them to trade to a place that's actually worse for them than our rationed endowment. And that can happen if the variance of the noise is greater than the variance of the underlying preferences. And that's exactly what happens here. So if the variance in the underlying preferences is smaller than the variance in the noise, then one person, one vote is better. But then QV is better. But if the variance in the noise is bigger, then one person, one vote is better. So I think that most of us think that the markets are better than rationing because we think that the heterogeneity in preferences is greater than heterogeneity in noise, and QV will be more efficient than one person, one vote under exactly the same circumstances. Okay, finally, I consider a model with aggregate uncertainty. That is one where people don't know the exact distribution of values within the population. And in this case, there's limiting inefficiency, generally. And the reason is because of something called the Bayesian underdog effect. So the Bayesian underdog effect is that, imagine that I'm a Romney supporter in the Romney-Obama election. Everybody knew Romney was probably going to lose, right? But if I'm a Romney supporter, I think the polls are just slightly off. I think that they didn't account for the fact that actually I should have been counted in that poll. And therefore, it's just ever so slightly more likely that Romney is going to get elected, which actually means that the election is closer to being tied. Whereas if I'm an Obama supporter, I make the opposite inference. I think that Obama is ever so slightly more likely to be elected, and that leads me to think that it's less likely the election is going to be tied, given that Obama was ahead anyway, right? And so as a result, the expected underdog gets too many votes relative to the expected favorite because of the people's estimates of being pivotal. Now, this, if you just think about it, can't cause very much inefficiency because it relies on the underdog continuing to be the underdog. Because if the underdog becomes the favorite as a result of this, then the whole logic flips. So there's sort of like an inherent limit on efficiency, but we haven't been able to translate that into a formal result yet. We just have a bunch of calibrated examples. And we calibrate it to the uncertainty that exists in real elections. And what we find is in this gay marriage example that we do, we get about 4% inefficiency under quadratic voting and 47% inefficiency under one person, one vote. So I think that this does cause limiting inefficiency. It's quite small. And unlike, the expected externality mechanism, it's still a well-defined mechanism. It just loses a small amount of efficiency. One really interesting question is common values in this space. And actually, Mehmet Ekmeki is working on a paper on that and has some preliminary results that look quite encouraging for quadratic voting, but I don't have those to report right now. OK, so let me just compare to these previous mechanisms. So remember, VCG, any two people will break it. Under quadratic voting, you'll always have to have a coalition that's growing in population size, often very dramatically in population size, in order to create problems for it. And by the way, under one person, one vote, collusion can occur as well. It's called vote buying, coercion, et cetera, right? Voluntary voting is not going to be efficient if people have other motivations, whereas quadratic voting actually may get more efficient in that case, and at very least does better than one person, one vote under quite reasonable conditions. The expected externality mechanism and implement the mean mechanism are not even defined when you have aggregate uncertainty, whereas quadratic voting sacrifices a pretty small amount of inefficiency in those cases. And again, is better than one person, one vote under almost all reasonable calibrations. In fact, the largest inefficiency loss we found from quadratic voting in one of these circumstances was 7%, which is reasonably modest. Okay. In conclusion, you know, the idea behind all of this, from my perspective, is that the real world is a really complicated place. Like, if we're actually thinking about what quadratic voting is going to do in the real world's a really complicated place. And furthermore, the real world with quadratic voting is even more complicated than the world without it. Because at least we've seen the world without quadratic voting for like a long time, and we can sort of like get a sense for how that works. But like you throw quadratic voting at the world, and God only knows what's going to happen, right? So, so the way I think about how we can try to extrapolate out of sample in that way is not that we make a really specific set of assumptions and we, you know, hold to hell and, you know, high water with that specific set of assumptions. It's rather that the best we can hope to do is study a bunch of like reasonably plausible models that seem to capture some aspect of what might be going on in the eventual world with quadratic voting, and we see what happens with quadratic voting in those settings. And we just do that for a bunch of different settings. And we work out the equilibrium of those models in those settings. And then we view those as roughly like data points. And if we have a really, really complicated mechanism, as I would argue the VCG or the D'apremont-Girard-Verret mechanism is, with like lots of different moving parts, and those fit one of those data points really well, you know, that's a little bit like saying that like you can fit a line between any two data points, right? But if you have, you know, something where there's like a bunch of different data points, and it seems to fit reasonably well through all of them, and it's pretty simple. It's like the sort of rules that like you can get people who, as we'll show tomorrow, you know, don't even have a high school education to like play with and sort of, you know, give sensible things to. Then if it fits reasonably well with a large number of data points, you might actually think that that will extrapolate. This principle is used in machine learning a lot. It's known in like philosophy of science as Occam's razor. It's the idea that if you have a simple thing that fits a lot of data reasonably well, that's a reasonable basis for extrapolation. Whereas if you have like, you know, one datum and it fits, something fits that perfectly, there's a reasonable chance of thinking that's just overfit to that particular set of assumptions, and it's unlikely to extrapolate. And that's really the philosophy behind what I'm doing here. It might be a philosophy actually that's more broadly applicable within mechanism design, to try to just study things under a bunch of different assumptions and look for things that are simple enough that it seems unlikely that it would do well under a range of assumptions unless there was sort of some truth that it was getting at. Okay, so obviously you could do better results on all the categories I'm talking about. There's all sorts of enrichments, and you could actually prove all the stuff rather than just making these approximation assumptions. The common value setting is something I think is really interesting. One thing that I think Lewis is going to get at in his presentation tomorrow that I think is really important is, you know, my changes in motivation were fundamentally psychological changes in motivation, but I really want more sociological changes. I want to think about, you know, there's a democratic culture around the one person, one vote paradigm that's crucial to supporting how our society works. And if you read the Federalist Papers, like, you know, anyone sensible thinking about democracy thinks a lot of it's about the culture and the institutions built around it and not about the mechanism itself. And, you know, maybe quadratic voting is a better mechanism. Maybe it needs less support around it, but it almost certainly needs social support around it. So exactly what the nature of that, you know, sociologies around it and what sociologies would be likely to spring up around it is a really fascinating set of questions. And finally, all my analysis here was for one very particular form of QV, binary decisions with money. But in fact, the forms that we're implementing in practice involve artificial currency, and they involve multiple decisions, and they might involve things like Miles was getting at, where there's, you know, a continuous space of choices or multiple things like Nick was talking about. So for all those forms, it's not clear how much this analysis extends, and it would be really interesting to look at that. Anyways, I'll leave it there, and I'm excited for questions. Roger, did you have a question? Or you should take the first one if you have a question. Yes. Yes, please. Yeah.
I do have a question. I looked at a comment. I want to suggest. So Weyl's thesis is that that any problem in any factor that causes failure or costs or failure of politics under any system will cause it under quadratic voting. And I want to suggest I find that your argument very persuasive. I think I'd like to ask both this and the previous speaker to set aside for a moment the one implication of that is, people should use quadratic voting. Okay, yeah, but we're scholars. We're not likely to get. We should try. Good, but it's not like we're not even likely to get New Zealand. But good. I think quadratic voting. I would like you to do everything you just did instead as a point about if one accepts Weyl's thesis, which I'm on. This is a model that shows us a way to understand what kinds of factors cause political systems to fail to achieve what one might theoretically think on a more simplified model would be an efficient solution. Why we get distorted decisions, why we get a failure to provide certain public goods that could have been self-financing if only. And I think that's very interesting. The certain kinds of extremism is inevitably going to be overrepresented because it's overrepresented in quadratic voting, and damn it, you're not going to be able to come up with a better system than what quadratic voting does in these. So I think you've got a very interesting approach for helping students to understand more systematically the costs of politics by using quadratic voting as the model of the political system that we're thinking about.
I think that's a fascinating idea, but yeah. So,
so this is a technical question. So the Vickery Clark Groves one, where there are two people colluding to mess it up, there must be a version of this where you say, instead of making it like a second price auction, it's like a 10,000th price auction, where you say, isn't there a way
that's not efficient.
No, of course it's not fully efficient, but wouldn't you get, in a large, suppose you have 200 million people in the country, and you use a 10,000.
What do you mean by 10,000th price?
I don't know. That's a question.
I don't think there is for a collective decision. I mean, the thing is, it's not an auction. It's something because you're taking a vertical sum of everyone's willingness to pay. You know what I mean? You're not looking at the opportunity cost associated with it. So
Isn't there some way of saying what's the thing that's robust to anything less than 10,000 people colluding?
Well, just try a version of this. You take like, are there 1,000 people that collectively swung? If so, they each pay like 1,000th of the cost.
Yeah, exactly.
Oh, that's what you're saying.
That would be just.
Yeah.
I'm just
It's not going to be perfect, but it seems robust. It seems more robust than the.
Yeah, I don't look. There are actually a fair number of things that you could do to Vickery Clark Groves to sort of like patch onto it, to sort of like make it less like enormously, sensitive to these types of issues. There's a variety of other issues with it, but my fundamental thing is I think Vickery Clark Groves, it's a very complicated and non-transparent system where afterwards you like find out what payment you made and like you're reporting some. To me, it's just like it's got a terrible user interface to begin with, and then going around with this thing that obviously has a terrible user interface and like sticking on patches that make it even more transparent and complicated. I mean, this just seems like a mess to me. But
No, I think that's probably true. But I think you make your case better if you compare your quadratic voting to patched up versions of the other ones. And I think you'll still win. But I think you want to compare yourself to patched up.
I mean, the problem is there's a zillion patches that one can do. And so it's like really hard to know what patches to do. And like the thing is, my real argument about Vickery Clark Groves is like this much broader thing. I'm not really trying to like do a sharp comparison against Vickery Clark Groves here, because I have a much broader argument for that. I'm just trying to look at the efficiency of quadratic voting and try to show that it's not as bad as what you find in these extreme Vickery Clark Groves things. Yeah, Itai.
So on the collusion issue, this is related to the other questions.
Yeah.
I still have some doubt, at least about the way that you're making the argument.
Yeah.
And I agree that VCG has a bad user interface and plenty of other problems.
Yeah.
But I have a doubt on two sides, both on the side of criticizing VCG and on the doubt of side of selling QB. So on the side of criticizing VCG, I know that there are all these problems like Oswald Milgram talked about, etc. I'm not sure that. I want you to spell out a little bit. I think the problems might be a little bit different in this voting case than when you've got, say, complementary goods and people are bidding in an auction. The example that you gave, it's extremely risky to do the particular collusion that you suggested, because if somebody else, if people vote the other way, you're going to end up having to pay a lot. In contrast, if I remember the sort of Ausubel-Milgram problems, and I even did something about this, I don't remember it so well anymore, but I think the idea was that you could actually do that kind of collusion in a non-risky way, so that you're not taking, a big risk that something really bad is going to happen. So that's on the side of VCG that it seems like I think you need a better argument, since it's weakly dominant, to report truthfully. There you take no risk. Yeah. Then I want to say something about quadratic voting, but maybe I've given you.
No, go ahead.
So about QV, I guess the thing I don't quite see yet is, look, suppose I get together with a bunch of my friends, and suppose we have perfect internal enforcement. And maybe some of my friends, they wouldn't have voted in the election or whatever, so they don't really care, but I care, and so I just convince them, to buy votes on my behalf. At least I can buy the same number of votes that I could have bought before at a lower price. Yeah. And then I might want to buy a few more votes. Yeah. And
I get the question. Okay. So on the first part, I think what you're saying is it is somewhat risk. I mean, I don't want to push it too hard. I don't fundamentally extremely strongly disagree with what you're saying. I think in practice, VCG, maybe not in the absolute largest, social circumstances, but in many practical circumstances where we have quite good internal information, and we know that we can get a dramatically better outcome for both of us by engaging in something, and we're friends in a long-term repeated thing. I just think in practice, VCG is going to be a disaster in those types of settings. And it doesn't require these billions of dollars and whatever. I mean, Hal Varian has a bunch of stories. He says every single year he ran VCG for a collective decision in his class in Michigan. There were all, to decide the date of an exam, there were always two friends who both reported an order of magnitude more than anyone else in the class did to get their favored date. And that's just it's sort of obvious that that's going to happen. I mean, and so, and they just completely undermine the whole operation of the mechanism. In contrast, in QV, I agree with what you're saying. That sort of thing is almost certainly going to happen to some extent in QV. I agree, Itai. And in fact, you definitely are going to want to collude in quadratic voting. That's not the argument I was making. The argument I was making is that that's a pretty continuous thing. Yes, you'll buy more votes. You'll buy the square root of the number of people in the colluding group multiplied by the number of votes you have. That'll give you more influence. But if lots of people in the population are doing that in relatively small groups, it doesn't really break the rough proportionality between values and that. It'll cause some noise in it. It'll cause some problems. I completely agree with that. It's just that in order to really change the whole outcome of the election in a really massive way, you have to have on the order of everybody in the population, or at least the square root of that, in order to really switch things. So that's the nature of the argument. It's not.
Example, they weren't taking a big risk, but somebody would really care about something else, and then they would have to make a large payment.
Well, I mean, the other thing I would say is that a lot of these large payment things are not credible. It's there's just no way that if somebody says $1 billion this way, you really force them to pay $1 billion. You know what I mean? So look, I mean, there's this is what I'm saying. I just think at a fundamental level, I'm just trying to formalize it a little bit, but at a fundamental level, VCG, it's just it doesn't make a lot of sense. It's not like a system that you're ever going to get people to be able to work with or understand or whatever. And so I'm just giving one example of that. I should move on to other questions. Yeah.
So one, you'll immediately catch what it says, but the statement you made on what is the relationship between sort of the variance and noise to the variance of underlying preferences, sort of being the sort of key first order way of thinking about it, does strike me as basically correct. Yeah. Or if it's not, I don't know why not. But so a question with QV there is, part of the noise is my noise in understanding how much I'm supposed to vote. So if we have a large election, like Romney-Obama, and if we were to ask people, let's say we've been running QV for 20 years, we know we could ask another 1% might vote as well.
Yeah, and that's in fact exactly
yes. So if we asked people, and we could get honest revelation from a large mass of people, what's the probability of pivotality that you have in your mind? And we computed the variance of that distribution. I think it's very easy to imagine that variance is larger than the variance of values. That people with very similar preferences might be having many orders of magnitude difference.
The proportional variance.
I'm sorry?
The proportional variance, you're saying.
I'm saying that so when I'm deciding how much to vote, I'm multiplying the probability of pivotality times my utility.
Yeah.
The noise and the estimation of probability of pivotality can easily be orders of magnitude, much more than utility. So, of course, if all this...
That's like, the theorem stands. I mean, it's one way or the other, I agree, yeah. But the thing is, in the non-mean zero case, that's not true. So in the non-mean zero case, Lewis, then none of that matters. And as long as it's uncorrelated with the value, you still get the right outcome.
No, I was just commenting on the sort of trying to benchmark what we And the other question on collusion is on collusion, which relates to some of the other comments. And I know in the paper, when you're trying to be rigorous about putting collusion into the model, one's doing things like there's one collusive group of this size and there's this common knowledge about it and things like that. But if we don't know how many collusive groups they are, if people have different views about which group, maybe the left wingers think the right wingers are more likely to collude, or maybe they think the right-wingers are more likely to collude because they know them and they see it going on. We don't know what the size of the groups will be. Are there 3 collusive groups, or are there 3,000 collusive groups in a large election? At that point, again, it's clear that if it's all noise, so that most people are behaving in the normal way, then things work out well. But if we put an underdog effect with that or something, so if people think that actually their group is more the winning group is more likely to collude, now pivotality plummets. So now the vast sea of people who think that are casting almost no votes.
I don't disagree with anything you're saying, Lewis. I think, though, that one thing I've strongly found about this is that you have to work out equilibria. Like, there's a lot of like one-step deviations starting at some equilibrium and then saying, oh, but if we put in this factor, like what, then doesn't that mess everything up? And once you actually solve for the equilibrium under your new behavioral assumptions, it both turns out to be quite different than what you anticipated and often actually quite a bit more favorable to the mechanism. So
So I'll say, having had some states with you before, but now having actually read the paper and some of the other papers that I had read before, I'm sympathetic to that. But taking a core intuition that you give, which I think is good. So if we have one side that's sort of supposed to win, and then we have some collusion on the other side as anticipated, since that makes the election likely to be closer, that creates this counterbalancing force, which is just the kind of thing you're talking about. And not having worked it all out, but seeing that idea, that seems like that is how the mechanism would operate. But if the side that's supposed to win imagines incorrectly that there's going to be collusion on their side, then it will have exactly that effect, but with the opposite sign.
No, that's not. So literally in this model, that's not true, Lewis. So this is why I'm saying you really have to work, you have to specify the model and work out the equilibrium. Literally in this model, I've studied that case. I didn't put it in the paper, but that's not true. And the reason that that's not true is that collusion on the winning side hardly changes things, whereas collusion on the losing side changes things dramatically because they're expected to be extremists, and therefore that causes like a much larger change in the chance of being pivotal. And so it's just not, like, I agree, there might be some model where you would get the effect you're describing, but like it's not as easy as you would think to actually write down a completely internally consistent model and solve it where you get that effect in equilibrium.
And you have the extremists on the other side being like orders of magnitude more extreme than extremists on my side because we have the tail thing with the asymmetric.
No, they don't have to be orders of magnitude more extreme.
The people colluding on my side are also...
No, but that doesn't matter. That's not the force that drives them to move their votes so much more. It's that the people on my side, they already know that they're winning with probability 1. So even if no matter how extreme their preferences are, they're never going to vote very much. The people on the other side are losing with probability 1. And they know that if they collude, they could change that to a situation where they would win with probability 1. So like there's an asymmetry in the structure of the equilibrium.
It's sort of common knowledge across the group that's doing this.
Yeah. And so, like, look, if you have aggregate uncertainty plus that, but then with aggregate uncertainty, you know, the extremist thing doesn't happen anyway. I mean, so you really have to specify a full model and solve it, because it's just like it's too complicated and too different from our intuitions about like standard situations that like taking these one-shot, these one-step things just like usually leads you to the opposite of like the correct intuition. If you know,
yeah, that's like the say tomorrow. In saying all of what you just said, we have an election with 130 million people voting.
Yeah.
And we're thinking that almost all of them are going to figure out the answers that you're giving rather than the suggestion that I was giving in figuring out how much to vote.
no, I don't think that's not how I think about this. Again, I think this is a very long-term thing where there would be a very long process of adaptation. There would be polling firms that would come up and their job would be to estimate chances of being pivotal. And there would be like a whole culture that would be built around this thing. Like, this is the reason why I don't believe in just taking, I view what you just said as another one-shot, you know, one-step deviation from the thing. You have to actually think about like, what's the world that we're thinking we live in, and what would be the equilibrium in a world like that, you know? Not just like what happens in our current world if we immediately, you see what I'm saying? So, yeah, I want to get David's question.
What are some of the inputs that could cause false positives, and how can those be controlled?
What do you mean false positives?
You know, noise in the data, false data, you know, different types of things. You know, a result that wasn't intended. You know, what's the possibility that an error could occur in one of these quadratic voting scenarios?
Well, as I mentioned, just anything that creates noise in how people behave, it is going to propagate through quadratic voting, because quadratic voting faithfully like aggregates people's preferences. So if people are confused or wrong, that's going to create problems. Also, if people like are confused about their estimation of the nature of the equilibrium play, as Lewis pointed out, that can cause problems. It doesn't cause big problems unless it's correlated with values or the mean is equal to 0, because, you know, in that case, the noise sort of washes out. But yeah, Miles? Yeah. Oh, sorry, Mark? Yeah. Yeah.
Do you know how it works with evaluations that are independent? In other words, that I learned some.
It's sort of like the common values case. Yeah. It's sort of like the common values case, right? So that is the one case where I really tried to solve it, and it's damn hard to solve a model like that. And the reason that it's so hard to solve a model like that is that in addition to conditioning on what I learn if I'm pivotal about things, I also have to think about what's the chance that that event of pivotality is going to occur, and how does that affect the total number of votes I have. So there can be effects like the following. Imagine that people, and this is like anecdotally true in US politics, the people who have the most extreme preferences are also best informed about the things that are important to everybody. So if that's the case, those people might potentially like not vote more, which you think they would vote more because they have more information, but actually vote less because they happen to know that it's unlikely the election is tied. Whereas like the ignorant people might vote less. Now, there's sort of limits on how much that could really occur in equilibrium, because if that were occurring, like they're only doing that in cases when it is in fact unlikely that it's tied, and therefore it doesn't matter that much that they're doing it. And so, but solving for an equilibrium like that, even using all the approximations I know how to use, I haven't been able to figure that out yet. I might be able to do it computationally, but even there, I don't know enough about the structure to really know how to get a solver working on it. Mehmet has, in a very special case, a nice conjecture, which is that if the distribution of preferences is orthogonal to the distribution of information quality, and if conditional on any value of the aggregate information, the distribution of preferences is the same, then he thinks he can prove an efficiency result. But that's a very special case, right? So, you know, I don't know. Miles, yeah.
I was just thinking about this issue of collusion with the NGA and the quadratic voting. I mean, this doesn't speak to the equilibrium issue, but it seems like there's this big danger of collusion, and it's kind of interesting because in the pictures I was showing, in the case where it limits into quadratic voting, then it's only a tiny difference in direction that people are colluding over. So so they get a big benefit of collusion because in that representation, their arrows are almost the same direction anyway, because mostly it's just a tiny tilt. Whereas if you have the NGA operating like it normally does, you're gonna have enough dimensions that people are really quite different, and so there's this bigger tension over colluding because you've got different interests that you're kind of trusting the other person to sacrifice. And anyway, that's just
I think it has a lot to do with whether people's interests are like really aligned along some dimensions but really diverge along others, or whether they're aligned along all dimensions. If they're aligned along all dimensions, NGA type things or just any point-based system is going to kill the ability of collusion to do much good, because like we can't collude on everything, right? Collusion is always substituting from one thing to another in an NGA type system, right? Whereas in quadratic voting, it could be harmful. So that's one sense in which NGA type mechanisms are going to be more robust to collusion than quadratic voting that I can clearly see. But yeah,
you said it better.
Yeah, David.
One of the things I like about how you're thinking about this is you're moving beyond the theory in some ways and trying to think about how you can apply this in the real world. And what's nice here is you're sort of saying, perfect economic assumptions give us this in QV. But if we relax condition A, it goes to there, or if we relax condition B. So I'm curious if you've sort of remapped where you think QV is especially useful in society as you've seen various conditions come and go and matter or not matter.
No. I think that's an interesting thing to think about doing. I mean, I think what I've more learned is like things that I think would be complementary with QV to make it work well in other cases. So like, for example, I have been persuaded by this aggregate uncertainty stuff that a new form of polling that takes into account intensity of preference is really complementary to using this in the government, which is one reason why I'm excited about the work we're doing together on doing QV-based polling. I think another thing that I've learned from it is that like there's certain issues related to collusion that you should be particularly worried about and others that you should be less worried about. And that informs like design for security issues, which Sinu is going to be talking about tomorrow. So I've learned more on that side rather than about like what domains to apply it to or not. But
yeah, I was curious, you've articulated, you have all these sub-bullet points of different kinds of collusion, or different kinds of models.
Yeah.
And I'm curious if you got those from people studying the real world. Like, how did you come up with those? You said there were thousands, but you chose these three.
Okay, so in here I chose these three just because I think that those are like the most representative of the literature on explaining why people currently vote as they do. Here, these I thought were two natural extremes, and fraud versus collusion seemed like the two big concerns. Perfect and undetected, this seemed like the worst case, so I wanted to consider that. Internal problems people talk a lot about in collusion, people like defecting on a collusive agreement, so I wanted to include that. And the fact that people were suspected by the rest of society, that I just perceived that was something that like would solve the problem, and that's the main reason I stuck it in there. And I thought it's very realistic. And then mean zero versus extremist, those are just the two cases of the model. So I tried to do the minimum number of things I could to like cover all the things that I thought were important to cover. So, but yeah.
I wonder if you've given thought to how QV applies to situations where you're electing multiple candidates, not a single candidate. Is it just as simple as everyone votes for, allocates their votes among multiple choices, and then the top X vote getters are elected? Or are there additional?
So I would say two things. So first of all, I think that system is much less pernicious under a sufficiently comprehensive use of QV conditional on that system as it is at present. And the reason is that what makes one like single member first past the post so pernicious? It's roughly that like there's all sorts of opportunities for things being like not at all nationally representative, even though they're representative within each district, because you just like things like gerrymandering, but also subtler things than gerrymandering, right? And if you had QV being used at the legislative level and at the local level, that just wouldn't create nearly as much of a problem. Because imagine that like you had a choice between having one really strong Republican district and two very weak Republican districts. Well, under one person, one vote, you clearly want two weak Republican districts. Under QV, not at all obvious if that's being used at the national level, because the weak Republicans are just going to vote zero on everything, and the strong. You see what I mean? So even within that, I actually think, and this is one result that Richard Zeckhauser and I have been trying to prove, but that there's actually like sort of a independence of like electoral form from outcomes at some level result that happens if you use QV in a sufficiently comprehensive way, whereas that's clearly not true under one person, one vote, and that's one advantage of QV, because it's just passing through the cardinal values. So then I think really the structure of the electoral system becomes much less about the outcomes that you're going to get and much more about the information processing, like, you know, who should think about what and when, and less about like how it represents preferences. And that's how I think it should be. But that doesn't mean, by the way, that I don't, even within QV, agree with your point that it might be better to have multi-member districts. It's just that what drives that calculus is different. And in terms of QV for that, I think that the structure that you're describing, I think should roughly work. I haven't worked it all out yet, but
NGA has an answer to exactly that question.
Yeah.
So if you just have that simplex and you apply NGA to the multi-candidate voting problem, what you get is you have everybody rate the candidates, then you normalize the mean to 0 and the variance to 1, and then you add up the ratings, and then the one with the highest rating wins. That's what NGA implies about the multi-candidate voting.
Sounds interesting. Yeah.
So this idea that in a large N election, once we were settled into the new system, that people would be looking to like pollsters, political leaders, or others for sort of a ballpark estimate of probability to for them feedback and guide things. It does seem right. But when I then think back to sort of where that chain started, which is collusion, extremists, and things like this, pollsters with probability 0 will get the extremists, and they may actually want to shut up in the polls, and they certainly will not get the polluters. They'll get them with probability 0, and they certainly will not tell the truth to the pollsters. So people are voting in the way you described, taking sort of the poll results to tell them the probability. Then your automatic response mechanisms that were used in the results are sort of turned off.
Yeah, no, I don't think I agree. And the reason I don't agree is that if there's aggregate uncertainty, then we never get into an equilibrium where extremists play a role. And I think there's aggregate uncertainty in the world. And so I just don't think, I think the extremist thing is like an artifact of this particular thing.
Sort of staying within it all. And on collusion, I think it's a similar sort of thing. This notion, I mean, do the pollsters also figure out the probability if there's going to be colluding with extreme values and adjust the probability accordingly? Since they're probably not, they're going to be polled with probability 0 and they're going to tell the truth with probability 0.
Yeah, but the thing is, I don't know, I mean, I haven't studied collusion in the aggregate uncertainty model, which is I think what you'd have to do in order to coherently answer the questions that you're saying. And again, I don't like making guesses about things where I don't understand the structure of the equilibrium because it's just surprising enough, so. Okay, I think we're out of time. Thank you.